Good evening, class. This is a video tutorial on the proof of the distance formula. In case you don't know, the distance formula is distance between any two coordinates is x1 minus x2 whole squared plus y1 minus y2 squared, and we take the square root of everything here. Now, to prove this, we're going to take this in two steps. We're first going to see the distance between distance at same level. You'll see what I mean about level, put those in quotation marks. And then finally, distance between any 2 points. Okay, so let's take a look at number one first. Okay, so let's take a look at number one. I want you to take and consider the 2 points here. I'm going to draw a rough sketch of a Cartesian plane, or a number plane as it's also known. I want you to take and consider the distance between these points, this one and this one. And label this one. Well, if you take a look, they have the same y coordinate, right? So in this one, they'll have x, make that x2, and we have a y coordinate of y. It doesn't matter what it is, but this point will have a different x value, which is going to be x1. But it's going to have the same y value, isn't it? Because it's the same height. See? It's got that same y. So it's a y value here. Now, if you take and consider, we want to calculate the distance between both of them. So I'm going to label this one. That is an x horizontal distance. Well, let's label that a distance of x units. How many units apart are they? Well, if you just take a look down here, I'm going to drop little points here just to visualize it. This point is our 0, correct? Well, from here to here, that is a distance of x2 units. That's x2 length. Oh, sorry, not 2, x1 length. Okay, take a look. Let's say that that number was 5. That means it would have been from 0, it would have moved 5 units across, right? And this one is a distance of x2. So between these two, that's x2 units. That x1 units is this point here. What is the length of that line there? Wouldn't that be x1, which is this length from here to here, subtracted by this length here? So the horizontal distance, if it's at the same level, is just going to be x1 minus x2. Any 2 points that are along the same level. We could actually swap these, it won't matter. Okay. Now the same thing goes for if it's a vertical distance. So let's take another very rough sketch of 2 points that are along the same y-axis. So here's x, that's y. And let's consider the 2 points. We have one here and one over here. Let's label this one. Well, it has some value x. We don't know what it is, but it has a value of x. And it is some unit up. So it's moved from 0 to up here. let's label that y1. Okay. And let's label this one would have the same x, because it's along the same axes. That has the same x. And this, it's a different y value. So it's gone up, but not as much. So let's just label it y2. And we want to calculate the distance between them. So we want to calculate that length there. Let's label that length y. Okay, so let's use the same idea that we had for this one on the x-axis. Here's 0. And this here is y2 length. So this entire length here is a length of, so not y2, of y1. So if this were 5, this whole length from 0 to there is 5. If this were 6, from here to here, it would be 6. Which means that from 0 to this point, that is only this point here, that length, is y2 length. But we want to calculate what length this one is. Can you see how if we take y1, which is the whole thing, and if we subtract y2, we're left with y, which is what we want. So that there, so we know that y1 minus y2 is the length of y, this d here, this distance of d. Now what we do is we're actually going to use these two ideas to calculate the length of any 2 points. So now I want you to take and consider the following points. Once again, a very rough sketch. Doesn't have to be perfect. There's our x-axis. That's our y-axis. Let's make this point here. Use a different color. Let's make this point up here some point. Let's label this one x1, y1. And this point down here in the bottom left, let's make this point here x2, y2. How are we going to calculate the distance between these 2 points? So let me draw a line there. We want to label, let's label that distance of d for distance. How are we going to calculate that length? Well, what we can actually use is Pythagoras' theorem. For first, what we need to do is draw a triangle. So if we take this point here and draw and just extend, or just at least imagine that we have that point there going down like that. Same goes for this one. And if we extend this one like that, we now have some point here which is a 90-degree angle. We have now our triangle. There we go. And now we just need to figure out what is this length here. Isn't that some length of y? Because it's along the y-axis, isn't it? Same goes for this one. What is that length there? Let's label that one some label of x, because it's along the x-axis. And using Pythagoras' theorem, we can see that d squared is equal to x squared plus y squared. But we don't want d squared. We want just d. So it would be x squared plus y squared all square root. Now we're going to use what we just did for these two ideas, that they're on the same level. Okay, so we're going to use these and apply it here. Take a look. Let's figure out this x length first, from this point to that point. Well, if this is along the same level as this coordinate here, isn't this point here x1, and this point here, that's x2. Well, if this from here to here, that is a length of x1, and from here to here is a length of x2, isn't this length here, we've labeled it x, isn't that length here just x1 minus x2? That's x1 minus x2. So we already know that this x here, not x squared, this x is x1 minus x2. Similarly, okay, this height is the same height as y2. Do you see that? So that there is y2. And this height here, that height there is y1. So from 0 to y1, that gives us a length of y1. True? But from 0 to y2, that there is a length of y2. But since we only want this length, if we take y1, which is the whole length here, from here to here, and subtract y2, which is this segment here, we are left with y. But we know that y is y1 minus y2, which is what we had here. So substituting these groups, these two, into our Pythagoras formula here, we will get, well, x is now going to be x1, x2. x1 minus x2 squared. Plus, our y is now going to be substituted with these two values here. That's going to be y1 minus y2 squared, all square root, which in summary gives us the formula that we set out to prove, which is the distance between any 2 points is x1 minus x2 squared plus y1 minus y2 squared, all square root. Hope this gives you some insight into the distance between any 2 points.